In 2004, Donald Davis and fellow scientists at the University of Texas made an alarming discovery. 43 foods, mostly vegetables, showed a marked decrease in nutrients between the mid and late 20th century. According to that research, the calcium in green beans dropped from 65 to 37 milligrams, vitamin A levels plummeted by almost half in asparagus. Broccoli stalks had less iron. Nutrient loss has continued since that study. More recent research has documented the declining nutrient value in some staple crops due to rising atmospheric carbon dioxide, CO2, levels. A 2018 study that tested rice found that higher CO2 levels reduced its protein, iron, and zinc content. The climate crisis has only accelerated concerns about crops' nutritional value. That's prompted the emergence of a process called biofortification, a strategy to replenish lost nutrients or those that foods never had in the first place. Biofortification encompasses multiple technologies. One involves genetically modifying a crop to increase its nutritional contents, which allows for the rapid introduction of new traits. Another, agronomic biofortification, utilizes nutrient-rich fertilizers or soil amendments to concentrate particular minerals in plants. Lastly, selective plant breeding can produce new varieties, though it can take a decade or more to yield a single variety. Biofortification puts nutrients directly into the seed, as opposed to fortification, which adds nutrients into food once it's grown. Because of climate change, iron and zinc have been dipping by 30 to 40% due to excessive rainfall, cold and physical damage. Harvest Plus is an organization, and it provides global leadership on biofortification evidence and technology. It is currently working with governments in more than 30 countries, and its biofortified varieties have been planted by more than 100 million farmers across the world, predominantly in developing countries. By 2030, the organization estimates 1 billion people will be benefiting from biofortified foods. While malnutrition demonstrates the urgent need to increase the nutrient density of crops globally, biofortification will help as a band-aid, rather than a solution to the problem. But there are other concerns that nutrients are being lost at a broader scale than biofortification can replace. A limitation of biofortification is that it focuses on one or possibly two nutrients per plant, whereas nutrient decline tends to affect many nutrients simultaneously. Then there's the hurdle of accessibility. That there's not yet a consistent supply of biofortified seeds. Harvest Plus also intends for its biofortified seeds to cost less than traditional seeds. But those lowered costs are the result of government subsidies. For example, India has partnered with Harvest Plus to make biofortified food available for children, in a country with a high rate of malnutrition stunting youth's growth. Pairing biofortification with other seed changes, perhaps breeding them to be more drought-resistant, to further encourage stakeholders to invest in crops that better fit local growing conditions. All of our work is about adapting to climate change in some sense. Carbon dioxide levels can affect the nutrient levels in plants. We have to do this plant breeding just to keep up. Enhancing fruits, veggies, and beans is one approach, but if that's the only approach from the public policy perspective, it's kind of idealistic.